Welcome back to Future News. As always, an article linked to this groundbreaking research can be found in the description below. Space, the final frontier, has always been a source of fascination and wonder. But getting around up there isn't easy. One of the biggest challenges is powering spacecraft on long journeys. Regular rockets, while strong, can only carry so much fuel. Imagine spacecraft traveling huge distances without worrying about running out of fuel. That's the exciting possibility of solar-powered lasers, a game-changing technology that could completely change how we explore space. By using the sun's energy and turning it into powerful laser beams, we could send spacecraft farther, faster, and for longer than ever before. Solar-powered lasers could make space travel more common, environmentally friendly, and totally transformative, inspiring future generations. The idea behind solar-powered lasers is simple but incredibly powerful. It all begins with capturing sunlight, the biggest source of energy in our solar system. Giant mirrors in space, placed to soak up the sun's rays, act like massive funnels, collecting and focusing huge amounts of solar energy. This concentrated sunlight then hits a special material that turns light into laser light. When sunlight hits this material, tiny particles of light called photons energize the material's electrons, making them jump to higher energy levels. When these excited electrons go back to normal, they release the extra energy as photons, creating a powerful focused beam of laser light. This laser beam, now packed with the sun's energy, can be sent wirelessly across vast distances, powering spacecraft and other things. How well this energy conversion works is key to making solar-powered lasers a reality. Nature has come up with some brilliant solutions over millions of years. When it comes to solar-powered lasers, deep-sea bacteria give us a great example of how to capture and use light. These tiny organisms have special parts called chlorosomes that act like tiny antennae, grabbing and directing light energy towards areas where photosynthesis happens. Scientists are studying these structures, hoping to copy their light-capturing abilities in man-made materials. These nature-inspired materials could revolutionize solar-powered lasers, making them smaller, lighter, and more efficient. By needing less bulky and heavy equipment, it would be cheaper and easier to launch these laser systems into space. Solar-powered lasers have tons of potential uses in space. Imagine spacecraft traveling to the far reaches of our solar system and beyond, without having to worry about fuel. Solar-powered lasers could continuously power spacecraft systems, scientific instruments, and life support, letting us explore distant planets, moons, and asteroids in amazing detail. Besides powering spacecraft, these lasers could change how we travel in space, making it much faster to get around our solar system and maybe even to other stars. This method, while still theoretical, could allow for much higher speeds than normal rockets, perhaps shortening a trip to Mars from months to weeks. Being able to use and send energy wirelessly across space also opens up exciting possibilities for using resources out there. Solar-powered lasers are incredibly promising, but there are some big technical challenges to overcome. One key challenge is creating materials that can survive the harsh environment of space, extreme temperatures, radiation, and tiny meteoroids, while still working efficiently for a long time. These materials need to be light and tough, able to handle space travel and work reliably for decades. Another challenge is making the technology powerful enough for space exploration. While small-scale tests have shown that solar-powered lasers work, scaling it up to power spacecraft or even space stations needs big engineering improvements. This means developing stronger lasers, bigger and better light-collecting mirrors, and reliable systems for sending and receiving laser energy over long distances. Despite these challenges, the future of solar-powered lasers is bright. Because of this technology's huge potential, research and development are ramping up all over the world.